So I'm going to make some program file, and the first thing I have to do is just tell Ruby, hey, here are the other files you're going to need. So that you know about these classes I'm going to reference. And then I'm going to like do some stuff, right? So like I have this idea of like a fictional bank account and how a bank account could work. I have an idea of how you could transfer things, but now I actually want to like talk about two specific bank accounts and actually transfer money. So let's say my bank account and your bank account, and we want to transfer money. So I'm going to make bank account 1. So when I create an actual instance of the class, when I call the new method, it's going to return me a new object. So that's as if like we have some like bank somewhere, right? And I call them up and I say, hey, I want to open up a new account. And they say, okay, I'm actually creating you a new bank account. And so I need to like hold on to that. Like if they were like, your account number is 456, and I'm just like, that's not helpful. I have no way to now ever get back to my bank account because you just rattled off a whole bunch of numbers and I never wrote them down. So to me, the analogy is like I'm writing down my bank account number here. Now I have access to the actual bank account. I have like a reference to the object itself. And now I can call methods on it. Right? I could say like, what's my status? Right? If bank account had a method called status, in my actual program, I would be able to call its method on the object. So I have this blueprint now, and I say a bank account does really nothing. It has a method that does nothing called status, and in my program, I can now call that method. So I create a new bank account. Now I have like a reference to it, a variable that allows me to refer to that new object, that particular bank account that I just opened, and now I can call its method. Yeah. So let's say status returns so we'll say bank accounts start off with this initial property, which is amount. I'll say that status, if you have more than $1,000, so if at amount is greater than 1,000, we'll do that. Else you're broke, right? Okay, so now all bank accounts know how to tell me about their status, but they have this property called an amount, and all bank accounts will have probably a different amount. So now when we create a new bank account, when we create my bank account, I'm rich, right, and you're poor. So now when we call status, we should get two different results, right, from these two different objects. Okay, so let's run this program. Right. You're a baller, you're broke. We could also say, okay, maybe bank accounts, we want to know who owns it, right? So we could say, whenever we initialize a bank account, we have to give it how much money this person has and who they are, right? And so maybe we put, we use this variable and we add that into these methods, right? Now when we run this program again, it's going to say argument error, right? Because I forgot to change this, right? So now I'll put myself. So even though like I wrote Sylvia bank account as the name of the variable, it's irrelevant, right? It doesn't, the object doesn't know about that. But now when I run it, now Blake, you're a baller, Sylvia, you're broke, right? So the method is the same, right? But the way it is different for every instance is because we're referencing these instance variables, which should be different, right? You have a different amount of money than I do, but our bank accounts should function the same, right? We should have the same rules and all that. Cool? Awesome. All right. Yes.
Side note, like is program.rb equivalent to like the runner?
Is it equivalent to the runner in?
Like what you would normally put in the bin, like the runner.rb?
Yeah. Yes and no. I mean, a lot of times, like in bin, you're gonna have something that can run from the command line. That's like, so people will kind of like create it so that like you have like a nice like command line sort of like utility, which takes like a couple extra steps, but more or less, yes, it's the thing that's like actually going to run the program, which is pretty similar to like what you would put in bin. It's also just like, it's kind of just weird in general to talk about like that sort of thing, because most applications that you're probably familiar with or you use are long-running applications. It's not, Ruby's a scripting language, so you'd write a script and you'd just run it once. So it's usually just kind of this little one-off thing where I'll write Ruby and then have the Ruby interpreter run the program. But the most programs that we're familiar with are long-running programs, right? Like a web server or a web application or whatever. Just it only gets called once and then it like kind of runs forever. So, like just in terms of trying to like compare it to things, this is kind of like a weird, it's a bit of a weird case. All right, so I'm gonna get rid of this. Cool, so I got transfer and bank account. I'm just gonna run the specs and see what happens. Maybe a bad strategy. Okay, so it says can initialize a bank account. So I'm just gonna drive through this and talk about like how I think about these things as we go through. Again, like the thing to keep in mind is this is totally made up, right? We had some high-level requirements, kind of that you can imagine our product manager gave to us. Hey, we need to make a bank, right? We need to have customers that can transfer money between one another. And then I, as the programmer, said, okay, let me write a whole bunch of specs that determine how this, these classes should work that meet your expectations. So we're forcing you to make these bank accounts and transfer classes work in a very specific way, but it's totally arbitrary, right? You could just have bank account classes and not the transfer class, and you could tell bank accounts, teach bank accounts how to transfer money amongst one another. But this is like just one way of doing it, one way of modeling this idea that we need to transfer money between two bank accounts. So just keep that in mind. It's totally made up, totally arbitrary, but we're going to make the specs pass because that's what we do, right? Okay. So, bank account spec, right? So we know what this let does. Anytime I call Avi, it's going to make a new bank account with Avi initialized in it. So from looking at this, if I look at the spec and I see Avi, I know that it's going to return this code, which means that to make this code be able to work, I know that the new method calls what method? Initialize. So I know at the very least I need an initialize method, and that initialize method must take one argument. Not because it's the right way to do it, just because that's how our spec decided it must work, right? So when I look at the spec, I know that the only way this bank account class can work that will make this spec valid is if I have an initialize method and it takes one argument. So I'll make an initialize method with one argument. So at the very least, like, I need to do that, right? So let me see if that passes the first spec. Cool, so I passed the first spec, right? And I passed the first spec with like not a genius solution. I know that further tests are going to show me like specifically how this class needs to function, and probably what I wrote is insufficient. So now the next thing is we expect that once I initialize this object, I should be able to call methods on it, right? So I know that the bank account class must have a method called name. And when I call that method, that method must return the string Avi. Okay, so let's make that work. name method must return the string Avi. Cool. Okay, so now that returns the string Avi, and now we say that when we call the balance method, it must return the number 1000. Now again, all of this stuff is hard-coded, probably doesn't make sense, right? But when we do test-driven development, a lot of times we want to just do the smallest thing we can to make these tests pass, and hopefully if we've written good tests, right, the tests will guide us to how we actually want the class to work that makes sense. We don't ever want to be like actually hard-coding stuff as like the end result. Yeah.
So I just noticed when I formatted everything, I need to do a bundle install.
Yeah.
Is this new RSpec doing something like fast fill, or is it like one by one?
My RSpec is I have fast fill set as like a default. Okay, so now we expect we should have a status method, and that should return open. All right, so let me do that. Status method, that should return open. So we pass that. Now we'd like to be able to deposit money into the account. Undefined method deposit for bank account, right? So at the very least, I'm going to need to create a method called deposit. Why did we fail there?
Oh, it's calling the balance. It calls balance.
Can't change its name.
So it expects dot balance.
Oh, here we are. Okay. So can deposit money into its account, right? So we expect that when we call balance, it equals 1000. So will that work? It does. Then we call avi.deposit. So we need a deposit method at the very least. Now I get wrong number of arguments for deposit, right? So we'll take an argument. And now it says that the second time I call avi.balance, it should be 2000. Right? So now I know that my hard coding balance to 1000 is stupid. Right? It's not going to work. There's no way that I can have it be 1000 and then 2000. So I know that deposit really should be changing the value of some variable, right? And balance must be returning the value of that variable. So what I'm thinking is probably we're doing something like initializing a balance. Not passing an argument, right? Because Avi doesn't take the bank account class is not taking an argument other than the name. But we have to set some initial balance, and we said the initial balance is 1000. Right, and then we want the balance method to read out what is in that variable. And then we hope that the deposit method can change the value of that variable. So I need a deposit method that takes some amount, and I need to check what's my balance, and then I need to add the amount to that balance. And then hopefully when I call balance again, right, it just reads out of this variable. I've changed the value of this variable. So now we should go from 1000 to 2000. And we do. Are people with me so far? Am I going too fast? Okay. Okay. Okay, so we expect that it can display its balance. So we have this idea that the balance method is going to return a number, right? But maybe we also want to be able to kind of like print out like a more like customer-friendly balance display, right? So now we want to make a method called display balance. And we expect that it should return this. So we expect that it should display the literal string your balance is and then whatever my balance is.
Why not the at? Why not instant variable?
Good question. So I have both a instance variable called balance and I have a method called balance. So here I am calling the method balance, which is returning the value of the instance variable balance. In general, that's like how we like to do things, is call methods rather than directly access the state of a variable.
How do you know when to access the instance and when to access the method?
Great question. So when you're trying to change the value of something, the easiest way to do it and is to just directly access the variable and then change it. If you call the method, really what you'd have to do is you'd have to do something like this. You'd have to say, okay, there's a balance equal method. And then we'd have to make this say, okay, balance equals balance plus amount. So here I'll make it even more explicit. We'll use self dot. So here it's a method call, and I'm saying, call the balance method and return me the value of the instance variable balance. Add the amount we passed in to that, and then call the balance equals method. Call the balance equals method and have it replace whatever is in the instance variable balance with whatever I pass in, which is the old balance plus some new amount.
I have one more question.
Yeah.
Is that more scope appropriate to do it that way or the way you have it before?
What do you mean by scope appropriate?
Like convention points. Like
I think this is what people would normally do. Like in general, we're going to read Sandy Metz's book called Pooter. And she talks a lot about like how to access data, and like kind of one of the general rules is you want to like limit where you access data to the fewest places possible. All your bugs are going to come from data not being what you expect. So if you limit like access in and out of data, you're better off. So every time you kind of directly access a variable, there's a possibility that like you're going to screw up, and especially if you ever need to change how this variable works, you're gonna have to change it in like a whole bunch of different places. In my opinion, doing something like this is like the cleanest and easiest way to do it. But certainly when you're just like reading something out, like why not just like call the method that's designed to do that. I'll make this self dot so we're clear that this is a method call. I need a $sign. All right, cool. So now we have this like visual representation of what our balance is, right? So we're just going through and just defining these tiny little methods which do like tiny little pieces of the puzzle. All right, so the next thing we want is a bank account is valid with an open status and a balance greater than 0. So the spec says we're going to make a new bank account. We are going to call its balance equals method, right? This is the balance equals method, or an attribute writer. We're going to create another bank account. We're going to set its status. We're going to call its status equals method. Neither of these methods exist yet, right? Then there's a third method that this test says we should have called valid question mark, and it should return a Boolean true or false. Okay, so first method I need is balance equals. Oh, I just made balance equals. Cool. Balance equals amount. Status equals. And I'm just following the convention of an attribute writer that we pass in an argument called status, we have an instance variable called status, and we set that instance variable to whatever we pass in. We could call this whatever, like banana. Right? We don't care about this. But this name matters because this is hopefully going to follow the convention. And then we expect valid to be true for obby. We expect broke and closed to be false. So the test is telling us, like in words, how we should want all this system to work. So valid means you have an open status and a balance greater than 0. So let's write valid. Okay, so you're open and greater than 0, right? So open, we just need to ask ourselves, what's our status, right? So if self.status is open, right? And your balance, you can just call the balance method, right? Ask the balance, it's greater than 0. If both of those things are true, I'll return true, right? Otherwise, I'll return false. Absolutely. Do this also. Cool. No. Expect closed dot valid to equal false. Oh, does anybody see what I did wrong? Yeah, so earlier I hard-coded the status method to always return open. So when the spec ran and we set the status to closed, and when valid read out the value of status, status always comes up as open. So even though we change the status variable to be closed, the status method just returns open, open, open. So this is a stupid method, right? This was my hard-coded method from earlier. Status, by convention, should return us the value of the actual status, right? So that when we change it, we actually see methods give us a different value. Cool. So now we're starting to break earlier tests. So now in earlier test I had said expect avi.status to equal open, and it got nil. So let's look at that test. Okay, so if we call avi.status, right, and Avi just creates a new bank account with his name, Avi, how can we get the status method to return open?
You can initialize it to always be open.
Okay.
And then it needs to be changed and we can call other.
So what we can do is we can look at the code and say, okay, what are the only methods happening? The initialize method and the status method, right? If this is not changing this to be open, then it must be in the initialize method that we're saying, oh, okay, that must have changed some variable to be open and then status read out that variable. So my initialize method must set all initial statuses to open. So it's kind of like a lot of these, you got to use sort of like a process of like deduction by looking at the code that's running and saying, well, if these are the only things that are running, then it must be that in one of the two methods that's getting called, it's like doing something to change the state of my object. All right, so now we want to be able to close an account. Am I going too fast? What's that? Okay, sure, happy to.
Did you make valid method boolean?
I mean, I only did that because that's what the test said I had to do.
Okay.
But if I were writing this myself, which I did not, I would make it valid question mark because we want it to return a true or false. And that's the convention to communicate to people that, like, this method's probably going to return true or
Well,
false.
the question mark itself doesn't really change.
No,
the method.
just convention.
Okay, cool. Okay.
So, like, when I look at your code and I see a question mark method, without having to actually read through the method body, I just know that, like, you and I are both Ruby programmers, so I don't have to, like, actually read the code. I just know if you put a question mark at the end, I can just assume you're going to give me back true or false.
Question.
Yeah.
Did if self.status is open? Is there a reason why? I mean, why did you use self?
I'm just doing that so people can tell that this is a method call. Just to be clear.
Because all I did was I called
Oh, so I'm trying to like show people that in general we like to call methods, not read out of instance variables directly. The case I was talking about earlier was if you're trying to change the value of this variable, it's quite annoying to have to like call methods, and so just reading out of it directly is like fine. But in general, always call methods, just because like if you're always calling methods, if you ever change how that method works, you only have to change it in one place. If you're always reading out of your data directly, and then you change kind of how you want that data to work, you're gonna have to change it everywhere you directly read out of that variable. All right, last one, we should be able to close account, right? So we have some method called close account, and we expect that two methods are going to get called, status and close account. And we expect that when we call status, it will read us back closed, so we must be changing the value of the variable that status is reading. So I expect that close account must be messing with the status variable. So let's make a close account method. All right, and I know that it must just set status equal to closed. And that is my bank account. Okay to move on? All right. Say that again? Yeah. Sure. So this test does a couple things. We call the balance equals method, we call the status equals method, and we call the valid method. So it's hard to really like work out exactly how the valid question mark method should work, because there's a number of things that we could do in the valid question mark method that would make this individual test pass. So I just like read through all the code and I was like, okay, I see all the code that's running, but I don't. It's not exactly clear how we want it to work. And then I read the name of the test, and in the name of the test, we're just saying, okay, this is actually how this should work. So the valid method should look at the status of an account, and if it's open, and if it has a balance greater than 0, we want this method to return true. If it's either of those things is not true, then we will return false. So in my valid method, I'm just saying, okay, one conditional, I'm checking two conditions, and I'm calling my status method, which reads out the value of the status instance variable, and I'm saying, is that open? So that's the first part of my conditional. And then I'm saying, also, I need to check the balance. For this to be a true return, I need to check the balance, right? So I call the balance method, which is defined up here, which is an attribute reader, which just returns the instance variable balance. And if the value of that is greater than 0, then both of the conditions are met, and I should say this is a valid account. I should return true from this Boolean method. Otherwise, all other things shall return false. Cool? All right. So let's transfer. All right. So, again, how I'm imagining this on a high level working is like the transfer class is going to take two bank accounts, right? And we're going to like call methods on those bank accounts and figure out how to change the state of those two bank accounts, sending money from one to another, aka changing the amount variables in both of those bank accounts. Okay, so we should be able to initialize a transfer, right? So expect transfer to be an instance of the transfer class, so that's pretty easy, right? Okay, so I should be able to initialize this class. I wrote the initialize method, but it says wrong number of arguments. It's passing 3 in the test. My initialize method takes 0 arguments, so I need to give it 3 arguments. Okay, and now I can pass that, right? Again, we know that this doesn't make any sense. I'm just trying to pass the initial tests, and then it'll become apparent to me probably like how my hard coding like doesn't make sense and how we really want the initialize method to work as we see like the later tests. Okay, so it expects that there should be a method called sender on the transfer class, and that should return Amanda. So what is Amanda? Amanda is an instance of a bank account initialized with her name. Okay, so my initialize method is probably not sufficient then. So I need at very least a transfer method. Now I have a transfer method. No, not transfer, sender. Now I have a sender method, right? But the sender method expects to return an instance of the bank account class, right? It should return Amanda or the sender object, but we got nil, right? So we're not actually returning anything from the sender method. So what should the sender method be returning? What's that? So if I look at the test, it says the sender method should return this thing. So what is this? It's an object, right? It's a bank account object. So I know that the sender method must be returning a bank account object. So one thing I could do is this, right? So now my sender method is going to return a bank account object with a balance of 1,000, right? Because by default my bank account objects start with 1,000 and they start with a status of open, and I'm pretty close, right? Why is this not passing? Two different instances. So objects know that they're unique, and so we're comparing two different objects. So in the test, we're saying this specific Amanda needs to be the person that gets returned by the sender method. And I just made my own Amanda. So now there's kind of like two Amandas in the world, and we compared them to each other, and we said, are these the same? And Ruby said, no, you made one and I made one in the test, and I want you to tell me the sender is the one that I made, right? So how do we do that? Yeah, so we need to use this initialize method, right? So let's call it sender is the first thing, and let's hang on to that rather than just tossing it out, right? So when we initialize a transfer, we need to capture this information, right? So we're passing in this particular instance of Amanda. Let's grab her and save her into an instance variable, and that way later we can return it back with the sender method. Now we pass that. And then same idea here, right? And we expect the receiver to be also saved. We're just going to follow our attr_reader convention. Second thing being passed in the spec, right, is Avi. He's going to be the receiver. So let me grab him, save him in an instance variable, and then we can just read him out in the test. Cool. So we should always initialize with a status of pending. Okay, so we're going to call the status method, and we expect it to return pending. What's the easiest way to make that work? Easier than that. How do we make the status method return the string pending? Yeah, we could just hard code it. The test says we need to have the status return pending. Now we passed. We imagine that in the future that's not going to be sufficient, right? We'll change that as we understand like the different requirements. What should status really be doing? Well, we're not sure right now. All we know is that right now it'll always just return pending. Okay, we should also initialize with the transfer amount. If we call the amount method on the transfer object, it should return 50. We don't have an amount method. Let's fix that. Now we should get a new error, right? The new error is going to be Well, our method returns nothing, right? And the test says it should return 50. Okay, so let's make our amount method return 50. Now it does. Fantastic. So now we want to check that both accounts are valid. How do we do that? Well, we expect there's a method called both valid question mark. And we expect that to equal true. So let's run our test. Now we have a both valid method. And now our both valid method is doing nothing, right? It returns nil. The test wants it to return true. Still hard coding, right? None of this is going to make any sense. Now we expect that the transfer class has a method called scan. And what is transfer class? So transfer class is an object that we initialized. So we're reading out of this file here, transfer RB. We're reading in our transfer class. I don't know why we're doing that. And then we're actually scanning through that string and looking for the literal, we're using a regex, and we're looking for the literal words sender.valid question mark and receiver dot end and then receiver dot valid question mark. So somewhere in here we need to have these literal we literally have to have this code somewhere. This is a super weird, stupid test.
Right, because didn't we do a valid question mark in bank account? So I think it's just calling that method on both the...
Yeah, so what it's saying is it's going to read our class, and somewhere you have to have the literal, like you literally have to have this somewhere in, in the transfer class. So I'm going to make a fake method called hello, and we have to literally have this code.
That's ridiculous. I put that in my both valid method, and it wasn't even working. I have to make an instance variable or whatever new method for that. Call it in my both valid method.
It's not a good way to test it. It basically reads through all your code and just says, anywhere do you have the literal characters sender.valid question mark and receiver.valid question mark. What it's trying to do is it really wants you to say in your both valid method. So like I just hard coded both valid to return true, right? Which doesn't really make any sense. What I would imagine if I was writing this app for real, both valid should tell me is the sender valid and the receiver valid, right? So probably in here is where I should have this. In the both valid method, if both of these objects, I'm delegating to both objects, so I have a sender and receiver in my transfer class, and it's like, transfer class is like, well, how do I know if something is like a valid transaction? Well, really I have to ask both individual bank accounts, hey, are you okay and are you okay, right? And if you guys are both okay, then I'm okay. So it kind of delegates out to those two objects and says, hey, are you valid? Are you valid? So that's kind of what we're trying to enforce here, is that there's a both valid method, and it should figure out whether or not things are valid by asking the individual receiver and sender if they're valid. And I think we also wanted to enforce that you are actually calling the method sender rather than reading out the instance variable. So we talked about, right, you could just directly access the instance variable, or you could call a method. In general, it's preferred to call the method. So that's also what the test is enforcing, is you must be calling the method. There's much better ways to do that, but that's what happens to be here. And then I think the length to equal 1. Oh, you know why? Because this is here, right? The regex is going to see this and not notice that it's commented out. Another reason why this test is stupid. You guys still with me, or did I confuse you? In where? Okay. So what does the sender method do? Isn't it what? It's a method, yeah. So what does it do? How do we know what it does? Okay, well, so how do you figure out what a method does? So if I told you I'm going to call the hello method, what does it do? Where would you look to know what the hello method did? Okay, so where's the sender method? Okay, so it's right here, right? So if I see that I'm calling the sender method, to figure out what it does, I look at the sender method, right? And what it does is it reads out the value of the instance variable sender. So what is the value of the instance variable sender? We initialized it, right? So when we initialized it, we passed in a bank account object, and we just have to remember all of the things that happened previously before this method got called. So first we initialized it, we passed in an instance of bank account, which was, I think, Amanda. Right, so we passed this in, right, in here. Then we passed Avi in here. And then we said, okay, we're saving that into the sender object, into the sender instance variable, and the receiver into the receiver instance variable. And then we made methods that just read back those things. So here we're basically just saying, okay, this bank account class, let's call its valid method, and receiver just calls this other bank account class its valid method. The same method on both of them, but two different objects, right? One's me, one's you, because we're transferring money between each other. So one of us is the sender, one of us is the receiver, and we're just saying, hey, you guys both have this valid method. Let me call both of your valid methods. And if both of your valid methods return true, then this is like going to be a cool transfer. If it's not, then we have a problem. Cool? All right, awesome. All right.
Like, that last test is only running because it's hard coded. Right? The sender valid, receiver valid. It's only working and passing a test because it's hard coded.
I wouldn't say these are hard coded.
Because I did a Boolean for it and it passes. But,
you did a Boolean for what?
well, if sender valid and receiver valid equals true, else false. But it's valid. We never defined valid as a method.
Yeah, we did. So this valid is being called on the bank account class, right? And we worked on that here.
Oh, wait, so it crosses over or something?
Yep. So the method gets called on whatever is the object that is represented by this thing. So Ruby's going to evaluate step by step, right? So the first thing it's going to do is it's going to call the sender method, right? The sender method is defined right here.
Yeah, no, I get that. But like,
Okay. And just stay with me. Stay with me. Okay. So sender method is right here, right? So it's going to return us whatever is in the instance variable sender. What is in the instance variable sender?
It's whoever is passed out. Sender right now is Amanda.
Yeah. And what object is Amanda? What type of object is Amanda?
She's in. I don't know what type of object.
Well, how can we find out?
I'm not really sure.
Okay. Where does Amanda come from?
We just made it.
We just said her name and she just came into being?
Initially.
Okay, where? Show me where. What line of code?
She's named.
She's what?
No, she's not named. She's sender. She's sender. At sender is equal to sender.
Okay, but
In the initialize method.
okay, but where do we actually initialize her?
Not really sure.
Okay. So at the top we have these lets, right? And so Amanda is a bank account new Amanda. So this is the definition for the whole rest of the test. Anytime we reference Amanda, it's not just some like magical incantation, right? It's actually instantiating a new bank account. So when we call transfer, transfer is going to call on Amanda, right? And it's actually going to create a new bank account object and pass that in. And when it passes it in, she becomes sender. So that's how we know what sender is. We kind of like work backwards. And she is a bank account class. So we can only call bank account methods on Amanda, on the sender. Great.
Yeah. It's just,
Yeah?
I didn't understand that, you know, yes, you can pull stuff from other, like, Ruby files and iterate it through, like, stuff from bank account for valid that we made there. I know we made it there, but I understand we can still call it another file into transfer.
Yeah, that's huge. That's like everything. That's object-oriented programming. All right, so again, how does this work? We're calling sender.valid and receiver.valid. So the question that was just raised was, how do we know we can call valid on sender? Right? I don't see valid here. Well, we can call valid because we can call methods on objects if that method is defined on this object. So that begs the question, well, what is sender? Is sender a transfer object, or is it some other type of object? Well, how can we figure that out? We have to work backwards, right? Sender is a method. It must be a method in this class. It cannot be anything else, right? Because the implicit receiver is self, and self is this class. So sender must be a method. Where is sender defined? It's right here. So sender just reads out the value of an instance variable. Well, where does this instance variable get set? It gets set in the initialize method, right? Whatever gets passed into sender is going to be what's in that instance variable. Now, again, this is the blueprint. When we actually use the transfer class, I can pass in any fucking object I want, right? I could come into the spec and I could be like transfer new the Blake class and the Steph class, if those existed, right? And now the sender would be an object of type Blake and an object of type Steph. And so if we called sender.valid and receiver.valid, it would say no method error. There's no method called valid question mark on Blake, and there's no method called valid question mark on Steph. So passing in Blake and Steph is not smart or useful because these are objects that don't do anything, don't have any methods defined. So rather than passing in objects that are not useful, in the transfer we're passing in bank account objects. How do we know that? Because when we call transfer in the spec, it actually instantiates a new instance of transfer and it passes in Amanda and Avi. Amanda represents an instance of bank account. Avi represents an instance of bank account. So if we follow the trail, when these guys come in here, we come in here and we say, oh, sender is a bank account, receiver is a bank account, and that's Amanda and Avi. So when we come down here, we say, oh, okay, sender returns back that instance variable. It returns Amanda. And Amanda has the valid method defined on her, right here. And that's why that works. Yes and no. This would work. It wouldn't pass the test because the test insists that you literally write it one way. But functionally, it would be the same. Cool? All right. All right, so can we execute a successful transaction between two accounts? All right, so I need a method called execute transaction first. Okay, but it should do something, right? And we expect that Amanda's balance should be 950. It started at 1,000. So let's look at exactly what's happening when we do this transfer. So we call execute transaction, and Amanda's balance should go down to 950. Avi's balance should go up to 1050. This makes no sense to me because what I'm thinking is there's some amount of money that needs to be transferred between these two accounts, and I don't see that specified anywhere here. So the only thing I can think is to hard code in execute transaction right now that a transaction is always $50. I would think that that would be an argument to execute transaction, or somewhere that we'd set the amount of money that was going to transfer. But just reading the test, there's only a couple things that are happening, right? We're calling the balance method, which is already defined, so nothing can be happening in there. We're calling the status method, so nothing can be really happening in there. So execute transaction must be just defaulting to $50. All right, so execute transaction needs to change the, let's write this out. So it has to change the balance of the sender, and then it needs to change the balance of the receiver, and then it needs to change the status of the transfer to be complete. How do I know that this is happening in execute transaction? Because balance was already defined, right? So it's not doing anything new. This is not doing anything new. Status not doing anything new. All these are readers, right? They're just reading stuff out. So we know that like the work that needs to happen must be happening in here, and then the state is going to be reflected in these methods that read out the state, these readers, right? Okay, how do we change the balance of the sender? Anybody? Setter. Okay, so bank account, do we have a balance equals method? We do, right? So let's use that setter, right? That is our interface to change that variable, balance equals, and we'll say it is whatever the current balance is. Anybody know how to get the current balance? The balance method, right, on the sender. So we ask the sender, what's your balance, right? And then we add, no, we subtract 50. All right, so let's parameterize 50.
It wouldn't be better to pull amounts and so on. On top of the definition, give this method amount.
Oh, fuck. That's where amount is. Yeah, thank you. That's where 50 came from. So sender balance minus amount, right? And then how do we change the balance of the receiver? Same thing, right? Okay, so I changed the balance of these two guys, and then I have to change the status of the transfer. So I hard-coded the status earlier, right? We said that's no longer sufficient. So let's initialize the status to be pending, and then let's have the status method just read out the value of that variable, and then we need to edit it. Status should be complete. Okay, we passed that. Each transfer can only happen once. So we call execute transaction. We check the balances, check that it should be complete, and we call execute transaction again, and the balances should be the same. So we know that somewhere in execute transaction, we have to have some kind of guard against the transaction happening more than once. I'm assuming that guard is we're just looking at the status, right? We're not going to allow a transfer to happen again if it's complete. So the first thing is we can just say, like, return false if status is complete. Right. Cool. We can reject a transfer if the sender doesn't have a valid account. So we have a bad transfer, we call execute transaction. So a bad transfer gets Amanda, Avi, and $4,000. So I assume the third variable to my transfer class is the actual amount, right? We've had this hard-coded amount. So let's change this arg3 to be the amount, and let's actually use that data. change the amount to read out that variable. And now we need to use our both valid method, right? So we say transaction rejected, please check your account balance if it's no good. So we could say, let's grab this stuff. So I'm going to make just a nice method that contains the statement that we return when it's not a legit transaction. I'll make an invalid transaction method, which just does the opposite of both valid. So none of this is required by the test, but I just think this is like semantically like descriptive. So what we have to do is if the transaction is not valid, we must return this string. So rather than having this whole string be in here, I'd rather just have a method that returns that string, and then if I ever want to change that, it's just like right here. If I want to use invalid transaction in a whole bunch of different places, now it's like parameterized, and it just looks better to me here, right? It just describes an invalid transaction. Oh, thank you. We'll call it invalid transaction description. If invalid transaction. What is invalid transaction? Question mark. It just does the opposite of both valid, right? So rather than like doing opposite of both valid, in my actual method, like I just like to methodize stuff and have names make sense to me, so I don't have to like remember what's the opposite of both valid. I just do it once, right? I just say if both of these things are cool, like we're all good. So this sender valid and receiver valid. Now I need to go back there. So valid. So valid is going to check if my balance is greater than 0. So there's a couple different ways I think that we could achieve this. What I would love is like if I had maybe both valid is not the right thing to rely on. What I want is like to kind of like simulate this transfer and then ask basically each object like, hey, if I take away this amount of money from you, like, are we okay? So it's actually not really both objects I need to take money away from. It's only the sender, right? So there's some amount. So maybe both valid is not the best method to call to see if something's invalid. Really what an invalid transaction is not just whether or not both of these guys have more than $0. Really, it's if the sender has more money than the amount we're about to send, right? So this is a method that's going to return the amount of money that we're about to send, and this is a method that asks the sender what their balance is. And maybe even I could push this to the sender class, and I could like even methodize this. And I could say sender dot valid transfer, and I could send them the amount. And then in the bank account class, I could say, what did I call it? Valid transfer. It takes in the amount, and I could just say, what's my balance, right? And if my balance is greater than the amount, I'll return true. So if this returns true, I I basically need like the opposite of this. So it's an invalid transaction. If this is not true, if that's like confusing, we could change this to maybe this should be invalid transfer. And we have this return. If balance is less than or equal, no, if the balance is less than the amount, it's an invalid transfer. And now I can just say, right, like ask the sender if this is an invalid transfer. I don't know, right? I don't want to have to like know that information. It should be just like a bank account that knows like how much money they have. So I just ask the sender, hey, like I'm going to give you some amount of money and you just tell me like, is this valid or invalid, right? If it's an invalid transfer, you're going to tell me that's true. Like I don't have enough money. And then now the transfer knows this is an invalid transaction. And now in my execute transaction function, I have this nice, like, descriptive way of describing when something is, like, no good. So rather than, like, having all of this, like, crazy logic, like, right here to determine whether or not it's, like, legit, now I just have, like, a nice, well-named method where I just say, like, hey, is this cool? Right? And it's like, I don't really know. I don't really care. I'm just a transfer guy, right? And I just say, hey, sender, can you just do me a favor? Like, I'm going to, like, give you some dollar amount and you tell me whether this is cool or not, right? And I don't know anything, right? I'm just going to give you an amount and you tell me because bank accounts know about their money, right? Rather than asking the bank account in here, hey, how much money do you have? And I, as a transfer class, like I'm going to figure like all of this stuff out. I'll just like let you do it for me. Maybe that makes sense. So let's see if this passes. Cool. So then there's another part where we want to set the status to be rejected when we have one of these bad transfers, right? So I didn't do that. So let's just make this like this. Let's say status is now equal to rejected. No, what did I do wrong? Oh, I put the return statement above my status, right? So it exited the method immediately. So I have to set the status first, then return that. Cool. So now, right, I have this guard up here. I say, stop. If the status is already complete, don't do anything and just return false, right? If it's an invalid transaction, set the status to reject it, and then immediately stop and return whatever this description is, right? And I just parameterized it so I can change it anytime I want. Then I have the actual logic of the method, which is like, if we're all good, like, let's do this stuff, right? Another thing you could do is like, you could even like make this like even better, right? And you could just say, let's call these validity checks. And you could just put the whole thing in here, right? And so you could just describe this part of the method. This is really a unit of work, right? Checking to know whether or not like it's okay to run the transaction or not. And we could have this method return true or false if we wanted. I'm just going to leave it for now because I think I'm getting too confusing, but just to like give you guys ideas of how like you can continue to like make small methods that are well named and like super descriptive and easy. Okay, then we want to be able to reverse a transfer. So we need a method called reverse transfer. Now we have a method called reverse transfer. And we expect that it should just do the opposite, right? So we reverse a transfer between two accounts. We call execute transaction, and we move some money around, and then we call reverse transfer. We should just do the opposite. Okay, so reverse transfer should basically just do this, right? Again, like another thing you could do is you could like methodize this, right? Like these are like almost the exact same thing. So you could call a method that's like move money, right? And you could determine like which way the money's gonna flow, and then you could just call move money here and move money here, and just swap the arguments that go into move money. I'm not going to do that again because I think it may be confusing, but just again ideas on how to like make this better. And then they expect us to call the status reversed, so let's add that. And now it says it can only reverse executed transfers. Okay, so I'm not even going to read the test, and I'm just going to guess that we have some guard up here if status is completed. All right, we only want to be able to call reverse if a transfer has already been done, which means that its status would have been completed. Oh, thank you. Still no. Let's look at this back.
I literally solved that 5 minutes ago. That's driving me crazy.
What's the secret?
Well, what I was doing is I was calling the status of the individual banker. You need to call the status of the actual transfer. I'm not. So remove that add.
Oh, I did the opposite, right? I had it backwards. I was saying don't reverse a transfer if it's complete, rather than only reverse a transfer if it's complete. We could also just make that a method call. And that's everything. I actually don't have time to like go over anything else. I need to go home so I can go to the airport. But can you just hang and answer questions if people have?